ocean is deep. In fact, most of it is profound. Officially, anywhere that has a depth of more than 200 meters is known as the deep sea, but the average depth of the entire ocean is about 3.5 kilometers, and its deepest point is called the Challenger Deep, located in the Mariana Trench in the Western Ocean. Our ocean has a depth of about 11 kilometers. This means that most of the space available on Earth is dedicated to the deep seas. Scientists like to categorize different things, and the different depths of the ocean are no exception. From the surface of the Earth to a depth of 0.2 kilometers, it is known as the coastal zone. From 0.2 to 3 kilometers is called bathyal zone, and from 3 to 6 kilometers depth is called abyssal zone, and below this depth is known as hadal zone. The hadal area is mainly composed of deep depressions that were created by the tectonic subduction of the oceanic crust, and they carry very large abyssal plains up to a depth of 11 kilometers. But even here, the animals happily continue their lives, oblivious to the fact that they are completely ignored at this depth. Are the deep oceans calm? Oceanographers have discovered slow currents in the deep oceans. Indirect reasons show that deep oceans cannot be calm. One of these reasons is that the organisms above the sea continuously consume food minerals, namely phosphates and nitrates, and after death, they take these substances with their bodies to the depths of the sea. If there was no current to bring these materials back to the sea surface would be depleted of these minerals. Another reason is that if there were no currents to transport oxygen, the oxygen that was absorbed from the air could not penetrate into the deep sea, and as a result, due to the decrease in the amount of oxygen, life in the deep sea would not be possible. In fact, it has been found that oxygen in the deepest parts of the sea also has a suitable concentration. The existence of oxygen in these places can only be explained by the idea that there are areas in the ocean that pull the oxygen-rich surface water down. The reason for the emergence of these vertical currents is the temperature difference. The surface ocean water cools in the polar regions and therefore is drawn downward. This constant downward flow of water spreads across the ocean floor. Therefore, even in the tropics, deep ocean water is very cold, with temperatures close to freezing. Cold water from the deep ocean eventually rises to the surface because it has nowhere else to go. After the water reaches the surface of the ocean again, it warms and is drawn towards the North Pole or South Pole, where it is drawn down again. The secret of our existence. Earth seems to be the only planet that has subduction zones and active plate tectonics. Both the Moon and Mercury are considered tectonically dead. The tectonic activities of Mars are muted for now, and Venus has a very thick lithosphere with molten rocks moving upwards. On Earth, subduction zones form the continental crust, which can be removed from the ocean. It is speculated that without the subduction zones, the Earth would still be underwater and terrestrial life, including humans, could never have evolved. What does it look like down there? The water temperature in the depths is low and varies between 1 and 4 degrees Celsius. However, the hydrostatic pressure increases linearly by 1 atmosphere per 10 meters of depth. As a result, the pressure in the hadal region is something around 600 to 1,100 atmospheres. So the pressure at the deepest point of this area is equivalent to placing a 1-ton weight on the tip of your finger. Degree of salinity. The average degree of salinity in the ocean is 35 parts per thousand, 35 grams of salt in 1 kilogram of water. The minimum degree of salinity is found in seas that have a lot of rainfall and rivers that are full of water enter them. For example, the salinity of the Black Sea is about 20 parts per thousand and the Baltic Sea is 5 to 8 parts per thousand. In seas with low salinity and high evaporation, salinity is maximum, for example, in the Red Sea up to 41 and the Persian Gulf up to 40 per thousand. What creatures live there? Many aquatic organisms can be found in the hadal zone. The most abundant groups include proterians, bivalves and bivalves, amphipods and cucumbers. All these groups are found in the deep ocean and in groups. Contrary to what is advertised, the hadal zone is not a mysterious environment, and its inhabitants are not aliens or monsters from the deep sea. Rather, this zone is only a lesser-known area whose inhabitants are mainly snails, worms and sea cucumbers, and in higher depths, small pink fish and red shrimps are also found. But there are also scary things. In the 1970s, the Puerto Rico basin became a dumping ground for pharmaceutical waste. The figures are astounding. Over 5 years, more than 387,000 tons of waste material accumulated in this pit, the amount equivalent to 880 Boeing 747 airplanes. Additionally, during the failed Apollo 13 lunar mission in 1970, the spacecraft carried a radioisotope thermoelectric generator that was supposed to remain on the Moon. The reactor was made of 3.9 kilograms of plutonium-238 and was eventually released into the Southwest Pacific Ocean. This generator is buried in the deep pit of Tonga at a depth between 6 and 9 kilometers and will probably remain there in a radioactive form for a few thousand years. Severe earthquakes. The magnitude 9 Tohoku-oki earthquake that occurred near Japan in 2011 was caused by the sudden movement of a fault in the Japan Trench. This earthquake and resulting tsunami caused 20,000 deaths and affected 35 coastal cities. After this earthquake, 666 aftershocks with a magnitude of 5 on the Richter scale shook the region. The energy of large-scale earthquakes that occur in trenches is very high. The 2004 Sumatra Andaman earthquake in the Java Trench released enough energy to affect the Earth's rotation and shorten the day by 2.68 microseconds. The Tohoku-oki earthquake similarly managed to shift the Earth's axis between 10 and 25 centimeters, and as a result, the length of the day was shortened by 1.8 microseconds. How deep are these depths? One of the most common analogies in trench science is that Mount Everest could fit inside the Mariana Trench and have about a mile of extra space. This example is scientifically correct and is very important from the physiological and evolutionary point of view. However, discovering these depths is very difficult. But exactly how far is 11 kilometers? The Mississippi River is 11 kilometers wide at its widest point. The length of the island of Manhattan is about twice the depth of the Mariana Trench, and if we consider the average speed of Mo Farah's run in the 2012 Olympics, he can run 11 kilometers in 30 minutes. Given that we can easily affect our planet over much longer distances, our relative proximity to these points means that even the deepest parts of the Earth are highly vulnerable to our damage.